Differential equations. So we're going to solve for that constant. So yesterday we were just putting the c on there to represent the constant, and today we're actually going to solve it. So determine the equation of the function f of x that's passing through this point, for which the derivative is f prime. So it's giving me the discriminant here. It's not the discriminant. Why am I struggling with this? The discriminant's under the root sign in the quadratic formula. What am I missing? What is it? Derivative, thanks. I was like, I could not find the word. Okay. It's like the discriminant is b squared minus 4ac. Too much math floating around in my head. Okay, so let's underive it. Let's do the antiderivative of it, and we are going to work backwards to the original. Okay, yes, there we go. All right, so we know that the original function, if we look at the 2x, we know that it will be, we keep the 2, it will be an x squared. And what do we divide by on the bottom? It's 2, but it's because of that exponent of 2, right? And then we're going to keep the minus 1. This would be x to the 1 now, divided by 1, plus a constant. So we're going to have x squared minus x plus some constant. And so I'm purposefully writing this stuff out just because this is the kind of the rules, the way you do it. If your brain's not thinking, if you can't like math it out, this is the formula. This is the way it's going to make the most sense. So this is our original equation with this unknown constant. So really all we have to do at this point is we know that the original function passes through 0, 0. You substitute this into your original. So we substitute these values into the original and solve for c. So we know that
c goes to 0?
Mm-hmm. So we're going to have 0 equals 0 squared minus 0 plus c. So c is equal to 0. So we know that our original equation is f of x equals x squared minus x. That is the original equation. So if you have a point, if you know a point on the original graph, then you can solve for the constant. If you don't have it, like if you aren't given a point, then we're stopping at this place right here. But we got to add the constant in. Okay? We're going to do this here. If we leave it like this, we're going to have to do the chain rule backwards. And I don't have the brain power to do that. So I'm going to expand this and then multiply the 3 through.
Wait,
so
can't we just say that 2 plus 1 equals to 3, and then divide it by 3, and then murder the 3's, and we're just left with x minus 2 inside brackets cubed?
No.
Why?
Because if we were given this equation to derive, what do we have to use? We have to use the chain rule, which is super complicated, right? So let's not do that. I'm just going to expand this and actually multiply it out. That to me is way simpler than trying to figure out how to do the chain rule backwards, and I actually don't know how to do it. So you guys would be on your own and I'll be crying in the corner. So I think if you get one of these, the easiest thing to do is put it into like its polynomial standard form, and then we can just use the rules that are given. So we're going to keep the 3. X is going to a cube, and it's divided by 3. and then we're going to keep the 12. X is going to a squared, and it's divided by 2. And then we have the 12 at the end, so plus 12, that'll be x to the exponent 1 divided by 1 plus the constant. And if you don't need to do that step, like if you're confident just to go right to this one that I'm doing, I'm okay with that. Like, don't feel you have to write this if you don't need it. It's just, I'm putting it in there so we can see how we get it. So it's always, if this is your new exponent, it's on the bottom. Your new exponent's on the bottom. Like if you're looking for how that denominator is or how to remember that. Okay, so we've been given the point, but we've been given it in a different way. It's in the original function g of x, not g prime, but g of x. X is -1. What's y? 3. So this is the coordinate pair -1, 3. It's just a different way of seeing a coordinate pair or stating a coordinate pair. So again, we're going to substitute those values in there. I think one of the most common mistakes is switching the x and the y. Sorry, that's supposed to be a C, not a 6. I don't know where I got the 6 from. I did it again. Jeez Louise. I think I did my math right there. I was adding 6's all over the place. Is it 22? Oh, it is 22. So my equation, I'm not done yet until I restate the equation. G of x is equal to x cubed minus 6x squared plus 12x plus 22. And that's the original equation. So just because you solve for 22 there, you're not done until you put it back together. All right. Oh, look, word problems. Particle motion. We did that. So if we know this is displacement, st would be displacement. Velocity is the first derivative. Acceleration is the second derivative, right? So I probably should have wrote beneath it. So just a reminder, easy peasy. So we're going to be working backwards with acceleration and velocity and going back to the original equation. So it's like you're anti-deriving it twice. The rules still, they're exactly the same forwards and backwards. So we're going to work through this. Okay. We know acceleration of a particle is negative 9.8 meters per second squared. Hopefully you guys recognize that number.
Physics.
Gravity.
We're all in physics, right?
Ali, are you in physics?
I did the 12 one last year.
Oh, okay. So you're a little loaded.
I forget everything.
So negative 9.8 is the force of gravity, right? Do you guys use 9.8 or 9.81?
9.81.
Yeah, that's how I remember it too.
You taught Mr. Beck, so you should put the 1.
It's true, I should. Okay, so determine the expression for the velocity at any given time with the condition, the initial conditions that velocity initial is equal to 64 meters per second. What do we know about time when we're talking about initial velocity? Time is 0, right? So as soon as I'm talking about initial, I've got a time of 0. So just keep that in mind while we're doing part A. So if we know that A is negative 9.8, and I'm just going to leave the units off just to help us there. So velocity is the derivative before that. So we have to antiderive negative 9.8. Pretty easy stuff. So I'm switching to a V just because we know that V comes before A in our list of things. Or we could say A equals V prime if we wanted to do that. If that makes sense, because, yeah, that makes sense. Okay. So A is the first derivative of the velocity. Okay, so if we're working backwards, if we're trying to find velocity, what do we have here?
Negative 9.8.
Right, because we're related to time. So t, and it's to the exponent 1, divide it by 1, and then add the constant on there. So we've got velocity equals negative 9.8 t plus c. So you're not quite done yet because we have another piece of information about that. We have a coordinate pair. We know that when t is equal to 0, velocity is equal to 64. And again, I'm leaving the units off just so it doesn't get kind of cumbersome, but just know your answer. If you were doing any math with that, that should...
Now we c equals to 64.
Are you sure about that?
Wait.
I'm just messing with you. You're correct. You're correct. That's good mental math. So I'm just going to put it into the equation just so we remember that we're substituting it into the equation that we just found. So the equation for velocity is going to be negative 9.8 t plus 64. Determine the velocity when t equals 3. That's a nice, easy plug and chug question, right? And it's asking about velocity, and we have an equation for velocity, so it's just nice and easy. So 34.6 what?
Meters per second.
Meters per second. Okay, so the next part says determine the expression for the displacement. So as soon as I see the word displacement, really, that's the original function. That's the original function of the particle at any time if s is 16 meters at t0. So it's given us a coordinate pair again, so we know we got to find for that constant. So if we were using this notation, oh, I'm pointing at it and I'm not showing it. If we were using this notation here, it's going to be the displacement is equal to the integral of velocity derived in respects to time. Like, just if you want to see it that way, I don't think you need to show it that way in your math, but just, it's again learning how to read this stuff. And so the integral tells me that I'm solving for something. I'm not putting my lower limits or anything or upper limits on it. We know velocity is negative 9.8 t plus 64 dt, right? So all of this is telling me is to antiderive it. And that's what we've been doing. But if you see it that way, just know what it's asking you to do. So S is going to be equal to negative 9.8 t squared now, divided by 2, plus 64 t to the exponent 1, divided by 1, plus c. And then the next part is going to be to solve for that c. And Rahat, what is it?
Spelling of summer mass.
What? So again, we know that piece of information. It's given in the question. If t is 0, s
Oh,
is
it's
16.
16.
See, I gave you an easy one to do. So we know that s is negative 4.9 t squared plus 64 t plus 16. So that's the original displacement question. Are you guys okay that I didn't show the substitution? You guys are, I mean, it's t equals 0, right? And so the last question is determine the displacement for t3. Again, it's another plug and chug. You're going to have to trust my math on this. And the units on that one is just going to be meters because it's displacement. So it's pretty easy. It's just working backwards again. Like if you've been given acceleration, you have to go to velocity first, then you have to go to the original. You've got to do them in order that they happen, so that you can't skip steps. Okay. The ball is thrown vertically upwards at 3 meters per second from a height of 2 meters with the constant rate of acceleration is 9.8 meters per second squared due to gravity. Okay. This might not be obvious, but this is our initial velocity. And the 2 meters, again, might not be obvious, but this is the initial height. This is all where it's starting from. So we've given 2 coordinate pairs. We've given a velocity coordinate pair, because what would it be? What would the time be? 0. And we know the time would be 0 on the initial height as well. So again, just keep in mind, like you'll see it in a couple different ways, and we'll go from there. Okay, find expressions for the velocity and height s at any time if t is measured from the upward point of projection. Okay, so really, we're just doing exactly the same thing that we did first. We have to find velocity first because you're undoing this. So part A, so we got to do velocity first. So we know A is equal to negative 9.8. And you're like, we just did this question, Sky, and why do we have to do it again? The numbers are going to be a little bit different based on the constants. So we know that velocity is going to be negative 9.8 t plus c. And what do we know here? We know that the initial velocity is 0. So what's c? 3. So if we know t is equal to 0 and v is equal to 3, we know that our equation is going to be velocity is negative 9.8 t plus 3. Okay, you guys do the displacement. I'll do displacement, you do displacement. We'll see if we get the same thing.
displacement is one more back, right? Like one more.
One more back, yeah. Displacement, velocity, acceleration.
And then
Acceleration, velocity, displacement.
jerk. And then where's the jerk?
It would displacement, velocity, acceleration, jerk.
Because he's at the very end.
Yeah. Can I show you what I got? Do you guys like leaving it as 9.8 divided by 2, or do you like leaving it as negative 4.9, or you don't care? I like dividing it out because I don't like decimals inside of fractions. Okay, so when does the ball hit the ground? Welcome to grade 11. Quadratic equation for this one. Really, so when we are doing part B, like you might get a question that only says part B. And you would have to know to go back, get to your displacement, and then use your grade 11 tools to answer the question. Because now that we have a parabola, like that's just grade 11 stuff again. Did you guys get the same ones as I did? You got different ones?
No, I would say
Okay. Did I mess up that one? Okay, so let's talk about this in reality because we have to make a statement about which one works, which one doesn't. If we were looking at this, we know we cross at 2, we know it opens down, we know our x-intercepts. So if this is our initial, we know that this part of the graph doesn't exist. So when do we hit the ground again? It's the positive 1.01. And that is that.
Yeah, we're done another lesson.
I know. Okay, makes sense? Easy peasy? Like I said, this